And number 7 says find the volume of the solid formed with cross sections perpendicular to the x-axis that are rectangles of height 3. So I want you to grab a Play-Doh and try to make this shape. Think about what this would look like. We need to do a little drawing out, but you can do that. We'll do a lot of drawing here in just a second. But this really should be kind of a familiar shape. You should get it all figured out.
What's funny about it? Oh, I already see it.
The circle of 0, 0, 3.
Yeah. That's what you just said before. Got to. Thanks, before.
You're welcome. So number 7.
Number 7, we're just making it with Play-Doh right now. Feel free to draw it out as
You can leave.
wish to.
I like your next little face.
Base is a circle.
Why are you here? Weren't you?
Because I wanted to
be here.
You were?
All sections are perpendicular to the x-axis that are rectangles.
Still doing pretty good.
Last test. That's equation.
This is the wettest place.
Probably did use the brown place last year.
Not sort of. The sphere. Exactly that.
No,
Sphere.
no.
Not a sphere.
You're a sphere.
Oh.
LOL. I don't know.
Were you not here? It's like you're gonna have like a base, like a circle, but then you're gonna have like one end, like little squares coming up.
Pretty good.
Like bigger and bigger squares. Does that make sense? So it's gonna look like
You guys getting this?
Yeah, it's like a sphere.
It's a good.
Definitely not a
Not a
sphere.
sphere at all.
Come on. Where's your notes in your Play-Doh, buddy?
I have notes, but not Play-Doh.
Hey, can you hear me? Yeah. It's okay. Hush. Thank you. All right. Good deal. Okay, so I wanted to like do this kind of like we can do this question, find the volume. I also wanted to kind of use this to prove to you that this really works and to show you where something came from in the past. So check this out. If this is a cylinder, which we've kind of arrived at, I think, as far as what this should look like. Do you guys remember, like I said, I'm going to erase all this, so please don't write any of this down. Do you guys remember the volume formula for a cylinder from like way back in geometry?
Yeah.
Do you guys remember what it is?
V equals pi r 4/3 pi r.
Oh, yeah, that's where you went wrong. Pi r,
Squared h.
there it is.
There you go.
Pi r squared h.
Yeah.
So what is the height of this cylinder that we just made?
3.
3, and what's the radius?
2.
2, right? Because the circle is centered at 0, 0 equals r squared, so r would be 2. So volume is equal to pi times 2 squared times 3, that would be 12 pi. So using that old geometry formula, we'd come up with 12 pi. And by the way, if you ever had a question like this, and you're like thinking to yourself, you're picturing it, you're thinking, oh my gosh, it's a cylinder. Did you know you could just use the volume formula?
You could just use that.
Good math is good math. Now the odds of that showing up in the AP test are probably 0, or on one of my tests would be 0, but on the off chance that something like that did show up, realize that math is math. And unless it said, write an integral to show setup, or, in some way indicated that you got to use calculus, math is just math, right? And if you could do it correctly using non-calculus, that's totally fine. Totally fine. Okay, so let's remember that the answer, according to geometry, would be 12 pi. And let's do this with calculus, maybe show you a little bit where that formula comes from. So here we go. There's my y-axis, there's my x-axis. Kind of that standard perspective drawing that I've tried to do. Circular base looks like this. Yeah, let's try that again. Circular base looks about like that. Cross sections perpendicular to the x-axis. Oops. Height of 3, whatever that means. Hey, Play-Doh should be put away now, Alex? Thank you. As in, no fingers touching the Play-Doh. For now. We'll get it back out in a second. All right, so there's your cross-section right there. It's perpendicular to the x-axis. So what does that imply when the cross-sections are perpendicular to the x-axis?
It's gonna be a DX.
Everything's in terms of x because it's dx thick. That's exactly right. So that's going to set us on a very specific course. All right, so we would say volume equals integral. Let's think about where we would start accumulating and stop accumulating. It's based on that circular base, right? We're going to go from there to there. We're going to accumulate from left to right, and -2 to 2 is correct. And we know that because of the radius. So -2 to 2. And then area of the cross-section is what goes inside, times dx. So what is the area formula for a rectangle?
BH.
BH, yeah, base times height. So the height is 3, right?
Yeah.
So I'm just going to put times 3. And base, a little more difficult. What would you guys say the base length is for this rectangle? Well, well, for sure it's not going to be consistent, right? Because if you're on the far left or right edges, it's going to be really, really small. Towards the middle, it's going to be larger. So it is going to depend on either x or y. What do you think?
2y.
2y. So if I look at it like this, I'll use a brighter color. Let's go with bright green maybe? No, that's not going to work. How about yellow? Wouldn't this yellow line be the whole base?
Yeah, that'd be 2Y.
And so then that yellow line being the whole base, if I start at the purple dot and move up, creating a purple line, wouldn't that be half of the base?
Yeah.
And if you start at the x-axis and move up, isn't that the definition of what y is? So the whole thing would be 2y, like you guys said. So from there up to there, that whole thing would be 2y. So you come back over here, maybe we're excited, we think, cool, we got it, 2y, wait a minute.
That's in terms.
It's got to be in terms of x. But you know what? It's not that bad because we can just look back up here and use this to substitute.
Oh, sorry.
So what I can do then with this is solve for y. It'll be y equals square root of 4 minus x squared. And I can replace the y with that. So volume is equal to integral from -2 to 2 of 2 square root 4 minus x squared times 3. Still working okay?
dx, right?
Oh, dx, sorry. I forgot my dx. Okay, so a couple things you could do here. You could, the 2 times 3 is a constant multiple. You get that out. 6 integral -2 to 2 square root of 4 minus x squared dx. Maybe this is the moment of truth. Maybe this calculator was active on this one. Why don't we use Math 9 to figure out what the exact volume would be, and then we can compare that to 12 pi and see if we really do have the same thing or not. Should be.
Is there a way that you can just put the answer like into pi or no? Because like you can just say
Divide by pi.
like, the
You got
first
it on your
fraction.
calculator. You got the pi button.
Oh, okay, so just
Probably work out okay. Just like get an answer for this using Math 9, and then just go divided by pi. Then you should be able to see, hopefully 12.
That's right. Same thing.
It's the same thing? Okay. What was it with decimals?
37.6991.
Did you guys get that?
Yep.
30. Okay. So then if you divide that, if you take that whole decimal, I'm sure there's other decimals there. If you just divide that by pi, I'd imagine you'd get 12, leading you to realize that it's really 12 pi, like we found before. So anyway, believe it or not, way back when your geometry teacher, or whenever it was, 8th grade, said, hey, we got this cylinder thing, how to find the volume of the cylinder is pi r squared h, that formula is actually from calculus. We're accumulating an infinite number of skinny little cross sections across a circular base. That would be one way to look at it. And yeah, so they just gave you this formula, and you, like a trusting student, were like, oh, sure, that kind of makes sense. Now you know a little bit more where it came from. Kind of a cool thing. Okay, so you guys have any follow-ups?
is calculus like the basis for like all the other math, like algebra and stuff, or no?
Well, it's the basis for all the geometry formulas, like the volume of a sphere, surface area of a sphere, cones and all that stuff, yeah. I I suppose you could look at it that way. I mean, if you think about it, in Algebra 1, don't you look at slope an awful lot?
Yeah.
Slopes of lines. What have we done like about 30% of the time in here? Slopes of lines, right? So, yeah. I guess maybe the bigger point, Drew, whether you'd say, hey, calculus is the basis for all that, or algebra is the basis for calculus, the bigger point is it's all connected. What we don't want is to have you feel like, hey, algebra 1, it gets to stay in its own little box. Calculus, that's another whole little box. It's all tangled together. It's all the same stuff.
They're all boxes.
It's all just math. Oh, yeah, see, they're all nested together. Yeah. All right.
It's a box like
Maybe you can tell from the graphic that that's not something that I made with Desmos or something. That's actually off of an AP test, off of a free response question. So it says the region R, once again, is the base of a solid. And what's different about this is we are not looking at this in perspective, right? We're back to airplane mode. We're looking straight down on the drawing. And so the region R is the base of this solid. For this solid, the cross sections perpendicular to the x-axis are squares. Try to find the volume of this solid.
Do we need height?
You probably need some equations for these graphs, right? If I remember correctly from way back, isn't the curve y equals root x?
Yeah.
And the line is y equals x over 2,
Oh, yeah.
if I remember correctly.
Yeah.
So it's that. This is just a continuation of that stuff we did with Revolution. They're just using this base for cross sections instead of revolving. So this is all part of the same AP question, if I remember correctly.
Would they tell you the equations earlier, probably?
Oh, they would definitely tell you. Yep, definitely. I just didn't write them. I just forgot that I'd already given them to you and didn't rewrite them. Okay, so we're working on this to figure out what the volume of the solid would be. And I think we just have one left after this. So we'll see how this one goes, and then we'll move on. So first of all, we're talking about I'm going to try to give you a little perspective. Please check this out. Luke, that's pretty good. I think you and Hallie kind of tied on that one. You both did a real good job with the shape. So I'm going to try to give you a little bit of perspective here. What I would say is a cross-section could be represented like this. It's a little bit of a different perspective. Can you see that? So I'm trying to make it pop out at you. As far as like the cross-section is coming straight at you, and it's a square, right? And you could draw other ones here, would kind of overlap a little bit with that one I just drew. It'd be like that, more or less. Okay. So the first thing I think we'd think about here is that we are perpendicular to the x-axis with our cross-section. So that means everything will be in terms of x. It's going to be a dx thick cross-section. So I would say volume is equal to integral. We'll settle that in a second. Blah, 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 dx. The next thing I would do is recognize the area of the cross-section. They're squares, right? So what's the area formula for the area of a square? I don't like base times height as much. I think I would go with sides squared. I mean, that's true, but the base and the height are the same. So, I don't know. Your way would definitely work there, but I think I'd go with blank squared. The next thing I'm going to do is put in my limits of integration. So, with a cross-section that's perpendicular to the x-axis, we will accumulate in which direction? It's left to right, so we start where?
0.
And where do we end?
4.
0 to 4. And finally we get to the side length. So the side length, wouldn't it be fair to say that the side length is the distance, say from right here, this red dot, to that red dot right there? And furthermore, wouldn't it be fair to say, thank you, that on the far left edge, the distance between the red dots would be really tiny. And on the far right edge, it would be really tiny. In the middle, it would be the biggest, right? So the distance between them is going to be changing, so we have to express it in terms of a variable. What did you guys do?
It's going to be terms of.
I did root x minus x squared.
Isn't it really a high minus low proposition? That'll give you the difference in the locations, also known as the distance. So, sure, root x minus x over 2 would give you that distance. That would give you the side length of the square, side squared. And as far as setting it up, that's it. Can I play a little devil's advocate here? What if you were grading somebody's quiz and they wrote this? How would you mark that? Would you mark that correct or incorrect?
Minus
Minus a couple points.
-2.
Minus 2 points.
I think that's very fair.
I don't know what it's out of, but he said minus 2 points. Hopefully it wasn't out of 2
It
points.
just doesn't give you the right, it's not the right. It's not
Area.
right.
Wait, no, wait, is it right? Because it's squared, so the negative doesn't
Well,
matter.
but
But it's subtraction goes.
No, yeah, but it gives you
Yeah,
different.
but it's.
Well, wait a
It's
second.
like reflecting the graph.
Technically saying we're like going even more.
Listen,
X minus
this kid can say whatever he wants, but he got
Hey, what if you paired up with someone, I don't know what Jonathan's going to do, maybe you could pair up with Spencer there. What if you paired up with someone and one of you put in the one on the left on your calculator and the other person put in the one on the right? Pair your answers.
I already have an answer. I'll do the right one. Do both?
Luke is like, yeah, I'm good. You did both.
No way, it's the same.
Yeah, because the squaring.
I'd still give him -2 just to screw with the kid.
Because it's like justice will be had.
Like, no.
Still get -2.
I know, that's right. I'm hearing everything on that one.
So that means if you have to make a really small error, you should just, or no
Well,
errors, just
I'm gonna-
take automatic.
Maybe it could be the first negative percentage on a test ever.
I think what you said.
Negative 5%.
That would
You would have been better off just not marking it. No, I'm just kidding. Hey, did you guys see that it's the same thing?
Yeah.
So, this is a unique situation. It's similar to, remember when we did all the revolution stuff and how I said, like, within the parentheses, if you switch the order, it's still numerically correct, right? So, I'm with Ben on this one, that this one makes the most sense because we're talking about a distance. So, it should be the higher number minus the lower number. But the truth of the matter is that this is numerically equal to it, and it's because of the squared, right? You'd get negative numbers for all those, but when you square them, you get positive numbers. So I would give full credit for both, assuming that you did the Math 9 correct, or whatever procedure you had to do. I would definitely give full credit for both because they are correct. Now, if this were in play, if we did something like this, but it was a rectangle instead of a square, now all of a sudden high minus low would matter.
Yeah, because the base times.
Yeah, because it would just be base times height, and your base would be negative all the way through. So with a rectangle, it would matter. With a square like this, it really doesn't matter. Yeah.
Since it says just find the volume of the solid, could you leave that on like an AP question and just put V equals the integral from 0?
No, because it said find the volume. It didn't say write an expression for the volume of the solid.
Okay, so
That's all we've done here.
Okay.
So yeah, you'd want to complete this. So I don't know if it's Math 9 time or if it's time to use pencil and paper, but I just wanted to point out that both of these would work in this situation, but it won't always be true because not everything has square cross sections. So will you guys share what you got for that as far as Math 9 goes?
0.533.
0.533. So that's apparently the volume. And if this was Math 9, that's really all you'd have to show. Please remember, the rules with Math 9 are still the same. If all you wrote was this, 0.533, you get 0 points. None. Not a zip, zilch, 0, whatever. You get nothing. You've got to write what you plugged into the calculator. So the rule of thumb is this. If you find yourself pushing Math 8 or Math 9, you need to have written down what you're about to do on paper, full well knowing the calculator will do all the details for you. That convention still applies, so please don't forget that. Okay, you ready to do the last one? All right, let's do the very last one. This is back up here. Number 5.
It's 5, we skipped it.
Yeah, we did. Coming back to it. Full disclosure on this one, we'll get into a little bit of a weird area formula that I've found over the years that a lot of folks don't know about. But what I thought we could do here first is graph the base, figure out what this will look like with Play-Doh, and then we'll work with the numbers and the equations and such to figure out what the volume is. So, here is the y-axis. There's the x. All right, and let's see here, that top line is negative 1/2 x plus 1. So I would say that that looks something like this. Whoops. And then the other line is 1/2 x minus 1. So I would say, try that again. There we go. So let's see here. The base is formed by those two lines. Is what is x equals 0?
It's a vertical line to 0.
Yeah, or the y-axis. So the y-axis, of course, is right there. So can you see the region that's completely enclosed by that stuff? It's a triangle. That's exactly right. So we got a triangle right here. It's my triangular base. And then the cross sections that are perpendicular to the x-axis again are equilateral triangles. Do you remember what an equilateral triangle is?
All the sides are the same.
All the sides are the same. What are all the angles on an equilateral? 60s. Yep, they're all 60s. So here's my attempt. What did you say back there, Alex? You said you were close. I just wanted to hear how close. Oh, that was Spencer. I'm sorry.
The equilateral triangle was 30-degree angle.
Oh, okay. It's all good. I was just kind of curious.
Alex?
He's reading your mind.
Yeah, maybe I'm hearing things. Pretty scary. All right, so does that make sense the way that I've drawn it up there with all the little cross sections? So based on that, can you take your Play-Doh and try and draw or create that from the drawing? Draw it with Play-Doh. I don't know how that would work. No more new stuff. This is it.
Play-Doh on the test.
No, you got to use your brain. So here we go. Hey, hello.
Hey, guys.
Here we go as a polite way of saying be quiet. Let's get started. So we're going to write volume equals. Integral, we don't know yet. Integrand, we haven't thought about yet. Maybe let's talk about the thickness. We're perpendicular to the x-axis, so the thickness of each cross-section, dx. It's important because that means that everything else is going to have to be in terms of x for this to work for us. Area formula is, I don't know if I'm going to go with that because I think that the base and the height relationship is going to be a little more challenging than you think. So I'm going to hold off on that for the moment. Let's go ahead and do the limits of integration. That'll be, to me, the next easiest thing. When we are perpendicular to the x-axis, what is the direction of accumulation?
Left, right.
It is left to right, so we're going to go
From 0 to something.
from 0 to something, I agree.
Will be where they intersect.
I just write really bad.
So 0 to something, where do they intersect out there? 2 is true. If you just count the slope, down 1 over 2 or up 1, right 2. If you just count the slope off, you'll see that they intersect at 2. And now this is where I'm going to go a little bit off the beaten path. You could do 1/2 BH as suggested by Drew. The problem with that is the thing that I brought up at the start, what are the angles on one of these equilateral triangles? They're all 60s.
Yeah.
And so the base would actually be pretty easy to find, but the height, isn't the height going to vary depending on where you are?
Yeah.
And so that would be a lot more difficult because you'd have to express that generally as opposed to just saying it's always whatever, the specific height. You'd have to use that. You'd have to use a little Pythagorean theorem to get it.
Couldn't you use,
So-
like, I guess I want to make it be hard, but
What I'm going to share with you guys, I don't know that this has ever come up on the AP test, and I think if it did, they would probably give you the formula. They'd probably scaffold it as such. I would do the same thing. The area formula, if you're interested in seeing where this comes from later on, I'd be happy to show you. But the area formula for an equilateral triangle is this. Side squared root 3 over 4.
Oh, because then it root 2.
I hope that you're listening. I hope that you're listening. I just said that's not something I would expect you to just like have in your memory bank. Something like that, I'd either have you develop it or I'd give it to you. It's just like not a typical area formula, but it is the area formula. I'll be happy to prove that to you in a minute if you'd like. So the question then becomes, how do you find the side length? Well, if
That's not high. It's not high.
so a y value, so I'm going to use yellow here. So a y value would be like from yellow dot to yellow dot, right?
And then would it be that plus the absolute value of like the other one, of the other side?
You could do it that way, but there's, I think, an easier way.
Is the first, like, color equation minus the second?
Yeah, it's still high minus low. Remember how we talked about that with area, about how even if one equation is below the x-axis, or maybe even both, high minus low will always give you that distance. High minus low. So to get the whole distance there, the whole yellow base, I'm going to just go high minus low. So my setup would look like this. Volume equals integral from 0 to 2. High would be
negative
Would be
1/2 x plus 1.
minus low would be 1/2 x minus 1 squared root 3 over 4 dx. And truly, if that's all you had to do was set it up, I would stop right there. There's a bunch of simplification that we could do, but if all I had to do was write down a setup, that's all I would do. Oh yeah, you know what? I need a big set, don't I? How about right? Oh, that's definitely a syntax error. There we go. How about that?
Oh, yeah.
No.
Okay. So side squared, so that whole thing squared, root 3 over 4 dx. So if you wanted to simplify a little bit, this would be a pretty straightforward simplification. It would be negative x plus 2, quantity squared, root 3 over 4 dx. You could obviously bring the root 3 over 4 out. There's a variety. You could FOIL. There's a variety of things you could do. And if you had to actually simplify this all the way to an answer using just pencil and paper, you would want to bring the root 3 over 4 out. You would want to FOIL it, and then it would be pretty straightforward from there. For now, let's use Math 9 to make sure that you are solid with that.
Simplify.
Yeah. Oh, yeah, you can use it.
Any Math 9ers?
Yeah. 1.1547
1.1547.
or 2 root 3 over 3.
Okay. Any confirmation on that for Dixon?
Yeah.
Got it. Okay. Awesome. Anybody interested in seeing where that area formula comes from?
Yeah, that's
I'm wondering, well, first off, would we have to know that for the AP test evening? No. Is that like, I was,
Another like 6 times.
It's another one of those moments where you were checked out.
I was paying attention, but I guess not to that.
Okay. Yeah. Well, maybe I'll show that to you in a second if you want. But let's talk about let's talk about the area formulas you'd be expected to just know, like in your memory bank of formulas. This is what I've seen consistently, and so this would be what I would quiz you on as well. You definitely want to know the area formula for a square,
Apply a circle.
rectangle,
Okay.
the basic area formula for a triangle. And one thing I have seen, and maybe something we could cover maybe Wednesday or Thursday, is this. Do you guys know what an oops, I lost an E there. Isosceles triangle is?
Yes.
Yeah.
Wait, how many sides are equal? 2 of the 3 are equal to each other. So I have seen a question kind of like this where you've got an isosceles right triangle and how that's arranged. You'll have to bring that one up perhaps as a review. So you definitely want to know square, rectangle, triangle, and then the final one I would say that I've seen pretty consistently is semicircle. So what's the area formula for a semicircle?
1/2 pi r squared.
Yeah, 1/2 pi r squared. Circle wouldn't work as well. Yeah. Okay, so to me, those are the big 4 that you want to make sure that you've got in your bank of memories as far as area formulas. Okay. Any questions, follow-ups of any kind?
Since we're reviewing Wednesday and Thursdays, the website still due tomorrow at midnight.
No, Thursday night. I think I changed that. Somebody asked me about that earlier. Sorry?